Okay, so we're going to continue with this intro to linear functions. We're going to spend this video looking at more about the intercepts, the x and y intercepts of linear functions. So if you remember from our discussion in the last video, an x-intercept is where it crosses the x-axis. So that's when you get nothing out for your y value. Okay, so this is going to be our x-intercept. And then the y-intercept is when you get something out, but that happens when you plug in 0 for x. Okay? So in order to figure out what is our x-intercept, I'm going to start with my original function, my original linear equation, and then I'm going to plug in 0 for y and figure out what do I get out for x. So I'm just going to solve this equation. What's the first thing you need to do here? Well, I need to add 10 to both sides. So I'm going to get 10 equals negative 2x. And then I'm going to divide both sides by negative 2. X equals negative 5. So if I plug in negative 5 into this equation, I'm going to get out 0. So that's my x-intercept. Our work for our y-intercept now, we start with our original function, minus 10. Y equals negative 2x minus 10. And then here, what happens is I'm actually going to plug in 0 for x. And I'm going to solve this equation. And I'm going to get y equals, if you notice, if you plug 0 in for x, that whole thing's going to go away. Why? Because negative 2 times 0 is going to give me 0. So 0 minus 10 is going to give me an output of negative 10. So if I plug in 0, I get out negative 10. Okay, so that is how you find the x and the y intercepts. You just have to remember, if you're crossing the x-axis, your x value is going to be something, your y value is going to be 0. On the same thought, if you're crossing the y-axis, you plug in 0 for x and see what you get out. All right, go ahead and try that in letter B. Find out what is your x-intercept and what is your y-intercept. Alrighty, so there you'll see the worked out for figuring out the x-intercept and the y-intercept for the linear function 4x minus 9y equals 18. Alright, in the next part we're going to look at some application problems, looking at representations of linear functions. So in example 3, a box of peanuts is being poured into bags at a rate of 4 ounces per second. This table shows this function relating the weight to the time. So we want to figure out what is the x-intercept and what is the y-intercept based on this graph. So remember, x-intercept is you plug in 0 for x and you get, wrong. Okay, the x-intercept is you get a number out for x and you get out 0 for y. So you plug in a number for x and you get out 0 for y. The y-intercept is what happens when you plug in 0 for x and you get out a y value. Okay? So if I look at this table, where is the y value 0? Right here. So this is going to be my x-intercept. And then where is my y-intercept? Well, where do I plug in 0 for x? Right at the beginning. So that's going to be my y-intercept. Okay? So the x-intercept, the coordinates for it are going to be 500, 0. And the y-intercept is coordinates are going to be 0, 2,000. So what do these mean? Well, the y-intercept is saying at 0 seconds, the weight of the bag is 2,000 ounces. Okay, so at the very beginning, before we start pouring, the very beginning, the bag is 2,000 ounces. And then the y-intercept is saying after 500 seconds, the bag weighs nothing. Or you can say all the peanuts have been poured out. Okay? So the y-intercept, that's our beginning. At the very beginning, we're at 2,000 ounces. We haven't poured out anything yet. But it will only take about 500 seconds to pour out all of the peanuts into the bags. Okay? So that's how you do it based off of a table. In example 4, you're going to be doing it based off that graph, this water drainage graph. So go ahead and try that out. Find your intercepts and then interpret their meaning. Alright, so in this graph of the water drainage, your x-intercept is saying after 4 minutes, there's no more water left. All of it's been drained out. Okay, the y-intercept is saying at the very beginning, before you start draining the water, so before the water starts draining, there are 200 gallons of it. Alright, so that's what your intercepts mean. So the intercepts, that's a very big concept that we'll be talking about, not only in this unit, but also in future units. So it's very important to know that vocabulary, know what they look like on a graph, but also know what they mean in a context of a real life problem. Okay? And the last problem for today in this video is going to be graphing using the y-intercepts. So in the previous video, we graphed by making a table. In this one, we're going to plot the two intercepts and then connect the dots. All right, so if I want to figure out where the y-intercept is, remember the y-intercept is you plug in 0 for x and you get out y. So that's exactly what I'm going to do. I'm going to take this function, I'm going to plug in 0 for x, and you'll notice something. The x value and that 1/2 are going to go away. And it's going to leave me with this one-step equation to solve. And when I do that, I'm going to get y equals -1. So that's my y-intercept, 0, -1. So I'm going to plot that point. And now I'm going to do the work to get my x-intercept. And you remember, your x-intercept is what do you plug in for x to get out 0 for y. So that's exactly what I'm going to do. I'm going to solve for x, but in order to do that, I'm going to plug in 0 for y. And this goes away. That term involving the y goes away, and I'm left with 1/2 x equals 3. And then I just got to solve this one-step equation. You have to remember, there will be some fractions. What's that fraction doing to x? It's multiplying. So how do I undo multiplication by a fraction? I divide. How do I divide fractions? Multiply by the reciprocal. So x is going to equal 6. So the x-intercept is going to be 6, 0. And if I plot that point, okay, and this is where we just got to be precise. Our precision has to be good because we only got 2 dots to connect. So I want to do this as best as I can, and that one wasn't a good one, so I'm going to try again. Okay, do our best to connect those dots precisely. We put our arrows at the end of that linear function. Make sure it's not super jagged. Make sure it looks like a straight line. Okay, if you have a ruler, that would be great. So one more example in this video, and then that'll wrap it up. So try B. Figure out what the two intercepts are, plot them, and then connect the dots. Alrighty, so there's the graph for our last example. Make sure your intercepts are correct. Make sure that straight line is there, your arrows are there, signifying that it goes on for infinity. Use a ruler if you got it. Just make sure your lines are looking straight. Okay? And we will continue throughout the next couple videos figuring out different ways to graph these lines. Until then, stay safe, be good.